Welcome back again to our today's episode. My name is Teacher Kasim. I'm a teacher of Maths and Chemistry, and I teach at Darushi Academy. We are still on the chapter of organic chemistry, and as we saw earlier, organic chemistry is a wide chapter. We started with the crude oil, hydrocarbons, alkanes, alkenes, and now we are on, we did also alcohols, and now we are on carboxylic acids. So carboxylic acids, I'll discuss the properties of carboxylic acids, their nomenclature as a displayed formula, and also discuss the chemical properties of carboxylic acids. But I would say carboxylic acids are actually the weak acids. They are just weak acids that have a pH of about 3 to 5. And carboxylic acids, they are called weak acids because they don't fully ionize to produce as many hydrogen ions as possible, but they partially ionize to produce a few hydrogen ions. So I would say that carboxylic acids are weak acids that have a pH of about 3 to 5. They are weak acids that have a pH of about 3 to 5. Examples of carboxylic acids include the examples of carboxylic acids include we have methanol, ethanoic acid, ethanoic acid, propanic acid, and so on and so forth. All the carboxylic acids, they have a unique feature in all of them. They have the functional group. The functional group of carboxylic acids is different from alkenes, it's different from alcohols, it's different from esters, and it's different from alkanes. So the functional group of carboxylic acid, the functional group of carboxylic acid is a single bond, and we have carbon, 2 oxygens and hydrogens. This is the functional group of carboxylic acids. This one can be as well be shown in the displayed formula form. So the displayed formula of the functional group is the displayed formula of the functional group of the carboxylic acids. So we need to go straight to naming and drawing the carboxylic acids, naming and drawing the displayed formulas of the carboxylic acids. So that is on the nomenclature of carboxylic acids. Nomenclature of carboxylic acids. Nomenclature of carboxylic acids. If you understood naming of the alkanes, naming of the alcohols, naming of the alkenes, it will be much easier to understand naming of the carboxylic acids, because they typically have a similar way of naming the carbon atoms. For example, the first member of carboxylic acids is methanoic acids. And last time we said meth stands for 1 carbon atom. So methanoic acid means that this is a carboxylic acid that has only 1 carbon atom. So I'll give examples of this. I'll give both the molecular formula, displayed formula, and structural formula. So in the naming, we shall have, we have the name, We have the name. We have the displayed formula. We have the name, displayed formula. And maybe we can have the molecular formula. Can have the molecular formula. And have the molecular formula. I'll give only 3 examples of carboxylic acid. The first member is methanoic acid. Methanoic acid as the first member. So meth stands for 1 carbon atom. It will be much safer for you to start by writing down the functional group. Then you add the number of carbon atoms depending on the name of that carboxylic acid. So this is the functional group of the carboxylic acid. Then because it's a meth, we are supposed to have only 1 carbon atom. And that 1 carbon atom is already in the functional group. So we are supposed to only add hydrogen atom at the back. And therefore, this is the displayed formula of the methanoic acid. So from the displayed formula, we can easily be able to find the molecular formula of carboxylic acid, that is methanoic acid. We have only 1 hydrogen, we have carbon, we have 2 oxygen and hydrogen. So that is what we call the molecular formula of carboxylic acid. That's methanoic acid. We can go to the second member, that is ethanoic acid. Ethanoic acid. And Eth stands for 2 carbon atoms. So I need to first write down or draw the functional group of ethanoic acid. So that is 1 carbon, double bond, hydrogen. Then because Eth stands for 2 carbon atoms, I already have 1 carbon atom captured in the what? In the functional group. So I'm only supposed to add 1 more carbon atom. So I'll have a carbon atom, hydrogen, hydrogen, and hydrogen. And from the displayed formula, we can easily be able to find or write down the molecular formula. So this is a CH3, then COOH. That is the molecular formula of ethanoic acid. Let me do one more example, then I go to the chemical properties of carboxylic acids. And that is on the propanoic acid. Propanoic acid. Our propanoic acid, 3 carbon atoms. We need to draw first the functional group. Then we had 2 more carbons, and we have hydrogen, 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 and hydrogen. This is the displayed formula of propanoic acid. I need to have, from the displayed formula, I can easily be able to write down the molecular formula. The first carbon has 3 hydrogens. Second carbon has 2 hydrogens. Then there's a C that's attached to oxygen and hydrogen. So this is a molecular formula of the propanoic acid. Now I need to go to the chemical properties of the carboxylic acids. Chemical properties of carboxylic acids. And remember when you were learning last time on the alcohol in our second episode, I think, we said carboxylic acids are formed from the oxidation of alcohols. So when alcohols are oxidized by strong oxidizing agents like the potassium dichromate 6 and potassium manganate 7, we form carboxylic acids. For example, if you have ethanol and is oxidized by strong oxidizing agents in the presence of a catalyst, that is the conc sulfuric acid, or rather dilute sulfuric acid, we form ethanoic acid. Propanol, propanoic acid. Butanol, butanoic acid. So these acids, these carboxylic acids are formed from oxidation of respective alcohols. So I'll go to the chemical properties of carboxylic acids. Chemical properties of carboxylic acid. Chemical properties of carboxylic acids. And carboxylic acids, by the way, they just typically behave like any other acid, like nitric acid, like sulfuric acid, like the hydrochloric acid. So they are typically like just any other acids. The only difference is that they are weak acids. So we shall say, the first chemical property is the reaction. The reactions with metals. The reactions with the metals. So carboxylic acids react with the metals to form a salt and hydrogen gas. carboxylic acids reacts with metals to form a salt and hydrogen gas. To form a salt and hydrogen gas. So let me give you the first example in this reaction, example 1. So example 1. I'll use methanoic acid, or rather, can I use any metal like magnesium, and I react with ethanoic acid, CH3COOH. During this reaction, there is an observation. There is a fizzing sound, or what we call the effervescence sound. This fizzing sound is actually due to production of hydrogen gas. Remember, during the reaction, hydrogen gas is produced, and therefore there must be a fizzing sound or a hissing sound. That shows that hydrogen gas is being produced in the reaction. So here, I need to determine first the formula of the salt. The name of the salt is called magnesium methanoate. Magnesium methanoate. The magnesium ion reacts with ethanoate ion to form magnesium ethanoate. So on the salt part, of course, here I'll have hydrogen as a gas, and of course plus the salt that will be formed after the reaction of ethanoate ion plus magnesium ion. I won't go into details how we form magnesium ion. This part we'll capture it in our next episode, but this part is basics on how we arrive at magnesium ion. What happens is that there is exchange of the valency. 2 goes there and 1 is here. So we shall have a CH3, COO brackets, there's a 2 Mg. This salt is called magnesium. This salt is called magnesium ethanoate. That salt is called magnesium ethanoate. And I can give you more examples of this. Remember, the concept, the whole idea is how do you form the salt? And what are the products of the reaction between carboxylic acids and metals? So, you given any carboxylic acid and any metal, you can be able to determine the name and the formula of that salt. For example, potassium, or rather sodium plus ethanoic acid, you'll form sodium ethanoate plus hydrogen gas, and many, many more examples. That is on the reactions with the metals. Let me go to the reaction with carbonates. The reactions with carbonates. That's number 2 on the chemical properties. Reaction with metal carbonates. Reaction with metal carbonates. Remember, typically, we know that when the carbonates react with acids, we form salt, water, and carbon dioxide. There is no difference with the carboxylic acids. So once you react carboxylic acids with any metal carbonate, you form salt, water, and carbon dioxide. Let me give you the first example. So example 1. So we shall say that all the carboxylic acids reacts with metal carbonates, to form salt, water, and carbon dioxide. Salt, water, and carbon dioxide. Again, during this reaction, just like we said during the reactions of metals and acids, this reaction also we have the effervescence sound. There is fizzing sound during this reaction because carbon dioxide is a gas and it's being produced during the reaction. This gas can be tested. You can confirm its presence by checking whether it turns lime water milky. The only gas that turns lime water milky is carbon dioxide. and therefore these are the products of the reaction between carboxylic acids and metal carbonates. Let me give a chemical equation to show this. Equation 1. Rather, I'll call it equation 2. So I can give you any metal carbonate, like the calcium carbonate. So if you react the calcium carbonate, the formula is CaCO3. That's a solid. If I react the calcium carbonate with any acid, maybe I can do the propanoic acid, CH3, CH2, COOH. This is a propanoic acid. Propanoic acid. So when these two react, of course, we shall form the salt, water, and carbon dioxide. So here we have the salt, which will be called the calcium propanoate plus water plus carbon dioxide. So here I'll have the water, carbon dioxide. I'll fit my salt here, down here. So the calcium ions are positively charged. Remember, calcium ions are cations, and they are formed after the loss of 2 electrons of the calcium metal. So once the 2 electrons are lost, we form the calcium ion. Calcium ion reacts with the propanoate ion to form calcium propanoate. So here is the propanoate ion, CH3, CH2, COO minus. So this is my propanoate ion. Once these two react, there is what we call the exchange of the valency. So the 2 down here and 1 here. So we shall have a CH3, CH2, COO brackets 2 Ca. That is what we call the calcium propanoate. That's what we call the calcium propanoate. The name of this salt is calcium propanoate, formed after the reaction of propanoic acid and calcium carbonate. So those are what we call the chemical properties of carboxylic acids. Chemical properties of carboxylic acids. And I don't think we have much on the carboxylic acids. But now we need to narrow down our discussions and talk about another subtopic, rather, and that is on the esters. Esters. And esters are actually formed when carboxylic acids reacts with alcohols. Remember, we know more about alcohols because we captured alcohols in our last episodes. We know more about carboxylic acids. So once the two react, we form esters in a process called esterification. So we go to the esters. So this is our next subtopic, the esters. The esters. So we shall say esters are formed when alcohols reacts with carboxylic acids. So esters are formed when alcohols reacts with carboxylic acids. Esters are formed when alcohols react with carboxylic acids. Good. The esters have the functional group of the esters. The functional group of esters. The functional group of esters has displayed formula. The functional group of esters has displayed formula. A single covalent bond, carbon atom, oxygen, single covalent bond. That is the functional group of the ester. This is what we call the molecular formula of the functional group of an ester. This can be shown in a displayed formula form. So this can be written down as carbon, double bond, oxygen, then that one is left open like that. So this is what you call the functional group of all the esters. All the esters must have that functional group. Now I need to show you how we form different esters. And by the way, let me add this by saying the name of the ester, the name of the ester, the name of the ester has two parts. The name of any ester, its name must have two parts. The first part is the alkyl part from the alcohol. Second part is the ethanoate part or alkanoate part from the carboxylic acid. So the first part is alkyl part is alkyl, and this alkyl is from the alcohol. And also we have the second part. The second part is the alkanoate ion. Alkanoate part. And this part is from the carboxylic acid. It is from the carboxylic acid. So an ester must have two parts. The name of an ester must have two parts. The alkyl part from the alcohol and the alkanoate part from the carboxylic acid. I'll give an example of the ester. So actually we can combine the two parts and see what we have. So we have an ester has the name alkyl alkanoate. Any ester must have the name in that order, alkyl alkanoate. Alkyl from alcohol, alkanoate from the carboxylic acid. I'll give an example of an ester. Example one. Examples of esters. So we can have an ester by the name methanoate. Can have an ester by the name ethyl propanoate. 2. Ethyl propanoate. An ester by the name butanoate. These are examples of esters, and I think we shall discuss in depth how we form these formulas and how we arrive at these different names of the esters. So now let me narrow down my discussion to formation of esters. 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 I don't need these. I need a bigger space here. So formation of esters. Formation of esters. Good. I'll give you a first example. Let's form an ester ethyl ethanoate. An ester ethyl ethanoate. An ester ethyl ethanoate. You see, from the name of the ester, you can be able to know which alcohol was used and which carboxylic acid was used. Like in this example of ethyl ethanoate, we know that we use the alcohol ethanol, ethyl. Then the carboxylic acid is ethanoic acid. So I need the alcohol ethanol plus ethanoic acid. Ethanol plus ethanoic acid. We form the ester ethanoid, and of course plus water molecule. This is a reversible reaction, this is a reversible reaction. And there are conditions for the esterification. This reaction needs warming. You must warm the reaction, and there must be a catalyst called the sulfuric acid. So conditions for the reaction. So here, I'll just say we need to warm the reaction, and we must have actually the hydrogen ions are needed as our catalyst. So let me give the word equation for this. Then I shall give the displayed formula and how we arrive at the ester. So this is the word equation. So the formula of the ethanol, let me give the structural formulas of this equation. So we have ethanol is CH3, CH2OH. That's the formula of ethanol. The formula of ethanoic acid is CH3, COOH. Remember, it's a carboxylic acid. Then we have this, I said, is a reversible reaction. So the name of the ester is called ethyl ethanoate. And how is the formula of the ester? So we shall have a CH3, COO, CH2, CH3. And of course, the water molecule is released in the process. This is what you call the structural formula, of the reaction between the alcohol, ethanol, and the carboxylic acid to give us the ester and the water molecule. Let me break down these to the displayed formula, because we must see this one in 3 dimensions. So let's see the displayed formula, how the equation would look like. The alcohol is carbon and OH. Then hydrogen. Remember from our last episodes, we have said that every carbon atom must have 4 covalent bonds. So that's the formula of the ethanol. Then carboxylic acid, which is our ethanoic acid, we must start with the functional group. That is the functional group of the carboxylic acid. Then 2 carbons. So that should be the displayed formula of the ethanoic acid. But now, let's see how we arrive at what we have here. Normally what happens is that a water molecule is released. So this part forms a water molecule. This oxygen reacts, or it is tied to the hydrogen from the carboxylic acid part to release a water molecule, H2O. So in the end here, that's how we arrive at the water molecule. It's released after the OH from the alcohol unites with the hydrogen atom from the hydrogen ion from the carboxylic acid. So what is left? Now we have to combine this part and this part to form our ester. So I start with the first part, the alkanoate ion, the ethanoate ion. Hydrogen, carbon, hydrogen, hydrogen. We have carbon, oxygen, O, carbon, carbon. Every carbon atom must have 4 covalent bonds. So this is our ester now. This ester is what we call the ethyl ethanoate. Thank you so much for your time. Until next time. Thank you.